All right, so 2-4 is called properties from algebra. So this is, we're baby stepping our way into something called a proof. Okay, we start with algebraic proofs and we finish with geometric proofs, and it is what like people hate the most about geometry. I'll just put it out there. The algebraic ones are not hard, okay? But as we move forward, you'll see it gets a little bit more challenging, because basically what it is it's something that you already know, or something you know how to do, and you're justifying your steps. Explaining to someone how you know what you know is basically the idea behind a proof. That's never going to be enough of an answer. Like if you put that as to why, like it'll say reason, and you put I'm just a genius, it's not going to be marked correct. Okay? I'm not saying you're wrong. I'm just saying that that's not the right answer for that type of question. So we start with the properties of equality. Okay? The addition property of equality says if A equals B and C equals D, then A plus C equals B plus D. All this means is you can take the same value and add it to both sides of an equation, and it will keep that equation true. So a lot of times you'll see this with values, like it would say something like if x equals 5, then I can do x plus 2 equals 5 plus 2. So you're taking and you're adding the same thing to both sides of your equation, okay? We use this every time we solve equations. You just didn't know the name of it before, perhaps. The second one is the subtraction property. And again, it's the same thought process. If A equals B and C equals D, then A minus C equals B minus D. So this time you're subtracting the same value from both sides of your equation, and it can be done because it keeps your equation true. So if x equals 5, then I can say x minus 2 equals 5 minus 2. I'm subtracting the same thing from both sides. That is true. The multiplication property of equality says if A equals B, then A times C equals B times C, as long as C is not 0. So we don't use 0 because it would cancel everything out. But multiplication just says you can multiply both sides by the same thing, and it would keep your equation true.
And CK equals 0.
Say again.
CK equals 0.
It cannot equal 0, correct. And then the division property says if A equals B, then A divided by C equals B divided by C. So now I can divide both sides of the equations by the same thing, and it keeps my equation correct. So you're multiplying both sides of the equation by the same thing. Division, you're dividing both sides by the same thing. So we will use these properties to solve equations, and this time you're going to not only do that step, but then you're going to explain why, and these are going to be some of the reasons why. And for that last one, C cannot be 0 because if we divide by 0, it makes it undefined. So in neither case, you want to use C as 0 in multiplication or division. All right, then comes substitution, reflexive, symmetric, transitive, and distributive sum and distributive difference. The first one is substitution. And it says if A equals B, then either A or B may be substituted for the other in any equation or equality. For example, if A equaled B, then 2A equals 10. I can also use B in the place of A if A equals B. So this is if A equals B. Then in the place of this A, I can substitute B, and that's called substitution. The reflexive property says anything equals itself. So if you think about it, if you were looking at your reflection, you should be staring back at you, right? Anytime something is equal to itself, we say that's the reflexive property. The symmetric property just reverses the order. If A equals B, then B equals A. If X equals 3, then 3 equals X. All of that would be the symmetric property. The transitive property is an if and then statement. If A equals B and B equals C, then A equals C. So if x equals y and y equals 3, then x equals 3. Transitive.
Go back.
After I get through this, yeah. And then distributive, so there's distributive sum and there's distributive difference, okay? The distributive sum just says take whatever's on the outside the parentheses, distribute it into the sum. It would get distributed into both parts inside the parentheses. And then obviously if it's a difference, it's the same thing except there's a minus between them. All right, properties applied to angles and segments. Oh, that top one is hard to read on your screen. Okay, so this is the reflexive property, which we just said can be used algebraically. We can also use it applying to segments and to angles. So the reflexive property says any segment equals itself. DE would equal DE. AB would equal AB. Okay, that's reflexive. Anything equals itself. An angle, we would just be talking about an angle. So this one says angle D equals angle D. It could be angle A equals angle A. Anytime something is set equal to itself, that's the reflexive property. Symmetric can also be applied to segments and angles. So if DE equals FG, then we switch the order for symmetric. FG would equal DE. If angle A equals angle B, then angle B equals angle A. That would be symmetric. We just switched the order. And then the transitive property can also be applied to segments and angles. If AB equals CD and CD equals EF, then AB equals EF. You take out the repeated part with transitive. So if angle A equals angle B and angle B equals angle C, then angle A equals angle C. So all of these properties can also be applied to segments and angles in addition to an algebraic statement. All right, example 1 says justify each statement with a property from algebra or a property of congruence. So look at A. It says if AB equals CD, then CD equals AB. What property is that?
Thank you.
Symmetric. Reflexive. No, symmetric. Symmetric. Okay? The order changed, right? We said AB equals CD, then CD equals AB. So we flipped it.
Oh, so it's symmetric.
2, 3 times x plus y equals 3x plus 3y, Nick.
The distributive, like the sum.
Good. Distributive, specifically the distributive sum.
Do we have to put in quotation?
I actually, on big ideas, I think this is going to be like a drag and drop, and I don't know that it gives you, if it gives you both, obviously you need to pick the right one.
All right.
It doesn't have to be parentheses, though, yeah. All right, 3, if 2a plus b equals 24 and b equals 4a, then 2a plus 4a equals 24. What is that?
So based on how you cheated.
Yeah.
I want to say transitive.
Close. So a transitive doesn't have a plus or minus statement in it. A transitive wouldn't be one object. So one object links to a second object, that second links to a third, so we bridge together the first and the third. This actually has an addition statement there, and what's happened? Sophia? Substitution. So we took B and we substituted in what B equals. So this is substitution. I think substitution and transitive are the most commonly confused ones. So if our original statement was that 2a plus b equals 24, but then b equals 4a, so we put 4a in the place of b, that is substitution. And then 4 says x over 3 equals 12, then x equals 36. What happened there?
Division property.
What'd you do to both sides? You multiplied. So this is the multiplication. And you can put POE for property of equality and shorthand that, okay? Again, I think on big ideas, this is like a drag and drop thing, but I'll look at it before we're done.
I've heard that if you write it out, you memorize it better, so you should post a PDF of it.
Oh, thank you for sharing. You can just like screenshot all your questions, write them out, and then go back and answer them.
Maybe.
Because you multiplied both sides by 3 to get to this. All right, example 2 is a justifying each step. So basically, they have worked out this problem on the left-hand side, starting with the very first step. And then each time you want to give the reason, how did you get from the previous step to where you are now? The very first step we say is given, because that was given to you. You did what? Yeah, you multiplied, right? We multiplied both sides by 3 here. We multiplied by 3. We multiplied by 3. So this is multiplication.
What does given mean?
Property of equality. That statement was given to you, right? Like you can't like invent your own thing at the beginning and I'll get the same one. So that's provided to you.
So that's what we would write on the quiz?
For the first one, yes, given. Okay.
Always given for the first one?
No, because you're going to get different stuff. But if it's an algebraic problem, yes. Then what, Jonathan? Oh.
Why number 4 on the last bit of multiplication?
All right. How did you get from B to C? What happened there?
You distribute.
Good. So this would be distributive.
Put parentheses, multiplication.
Parentheses difference.
Nice.
Okay, then we went to step D. How'd you get from C to D?
Yeah, so it's how do you get from C to D? Well, obviously division.
Nope. Calla.
No, I didn't.
You added both, right? We added 12x to both sides, which is the addition property of equality. And to get from D to E, you did what?
Division.
Good. Divided by 14.
You didn't even answer the question.
All right, this time you are going to solve it. So we're going to start with the original question, and then you're going to solve it, and then you're going to explain your steps. So the very first step would be the actual question,
Given.
and the reason is given.
Oh, you have to write the actual.
Yep.
She said that.
For
All right, so what's your step 2, Jonathan?
step 2,
Yep.
I added 4x on both sides, which is
So you're doing, I'm going to write what the in-between is here. So you add 4x. That's why I said it could be more than one way. That's why I'm asking him what he did. Okay, go ahead, Jonathan. So,
Step 2 would be 7x plus 2 equals 23.
good.
Got that from additive property.
Good. Then, what'd you do after that?
Step 3, I subtracted 2 on both sides, which is subtraction property.
Go ahead.
Step 4, I just divided both sides by 7, which is just an addition.
Good job. So if you switch and you first like subtracted the 2, then 2 and 3 could be switched. It's totally fine. Okay, you should still obviously get to the same answer at the end, and the reasons should still be the same. They just can be switched order. Questions? Yeah.
I had both subtraction and subtraction. I wrote
Did you get the same answer?
Yeah.
You can, so you did subtraction as in, did you subtract the 3x and move it to the other side? And then subtract the 2? Yeah, totally fine. As long as you're justifying your steps in the right way and you're getting to, obviously with an algebraic statement, you should get the same answer at the end. It's totally fine. All right, this one says solve for r in the formula p parentheses r plus 1 equals n and justify your steps. So again, I'm going to let you do it because you can do it in a couple of different ways. I'm going to let you do it and then you can justify your steps. All right, who wants to walk me through? Let's see if somebody else wants to try. If not, oh yeah. All right, so the first thing we're going to do is obviously rewrite it out. So p times r plus 1 equals n, and that's given. Okay, what is one of your options for the next step? Because there's more than one. Come on. Okay, so you distribute, so you got P R plus P equals N. Distributive property of equality. Okay, then what? Actually, you can do distributive sum. You don't need the. Where'd you go from there? Do you divide everything by P? Yeah. This doesn't mean you have to do it this way. This is a way to do it, but this doesn't mean you have to do it this way. So R plus 1 equals N over P. That's division. Okay, and then?
P over P is 1.
And then subtract 1.
Good job.
Okay, anyone do it differently? Mars,
I did it in 3 steps.
what'd you do?
I divided everything by P straight away.
Well, you have to use the given. You have to.
Yeah, I usually.
Oh, okay, okay.
But then the other one was distributed by I divided P immediately.
So here, from here, you did P R plus 1 equals N. And then you divided everything by P from here. R plus 1 equals N over P, division.
Yeah, and then
And then R equals N over P minus 1, subtraction. Okay. It's not like there's a prize for doing it faster as long as they're both right, okay? There will be a prize for skipping steps. So you want to just make sure you do each one. I mean, there won't be a prize for skipping steps. It will be wrong if you skip steps. So you want to make sure you do each one, but it doesn't mean that those would both get full credit,
What
okay?
if I just did it all in my head?
That would not get you credit. Yeah.
Instead of dividing P by turning P into 1P, just leave it as P and then subtract it.
But it has to be P over P if you divided.
Because you have to divide everything.
I did the first 2 steps the same,
Yeah.
but then I subtracted P from both sides.
And then divided by the other P. Totally fine. Yep.
Did you get the same answer?
You should, so it should end up being what, N minus P? No, you had,
And minus P over P.
you had P R plus P equals N. Then you said you did what? You moved the P?
Subtracted P.
N minus P, and then you divided it by P. So you kept it like that in 1? That's totally fine. Yep. So it would have been division, well, you would have done subtraction and then division. Yeah, that's fine. Just realize if this is one of the drag and drops that those are both right answers, but they won't both be there. Okay. All right, example 5 says you reflect the beam of a spotlight off a mirror lying flat on the stage as shown. Determine whether angle DBA would equal angle EBC. Sophia.
I said yes, and then the reflective property.
So yes, okay. DBA, which is this first angle here. No, DBA is this big one. DBA. You're trying to figure out if it equals EBC, which is this big one. Okay. And you know that these are congruent, right? This would be reflected on a mirror, so they are congruent. So if you had to actually work through, this is what a proof would look like, okay? A geometric proof. You would start with the given information, and the only initially given at the beginning is angle 1 equals angle 3. And that would be given to you because they are marked as congruent in that picture because they are reflected, whatever that information is actually given to you. Then you actually took something that is the same angle. I took this angle and I added angle 2. I added it to both of those angles. So I could say angle 2 equals angle 2. And the reason there, guys, is reflexive because anything that equals itself is reflexive. And then we added angle 2 to each. We did angle 1 plus angle 2 equals angle 3 plus angle 2. And that's the addition property of equality. We added the same thing to both sides. This whole thing is how a step-by-step proof would work. So right now it's just asking you what it is.
Oh, so
But eventually, you were fine. But eventually it's going to ask you to come up with a proof to describe that. And then I have to get from my numbers to the letters that were given. So angle DBA equals angle 2 plus angle 3. And angle EBC equals angle 1 plus angle 2. And that's the angle addition postulate.
That took a while. I can say I'm right.
And then the goal is to get to the end, that is DBA equals EBC. And that would be substitution because we already said 2 plus 3 equals 1 plus 2, and now we're giving them a different name. So this is what your future looks like, folks. Like, not necessarily tonight. Tonight we're going to baby step our way into it, okay? But that's what a geometric proof looks like. Do you know it's true? Yes. And then prove it is the back end of it, okay? And sometimes sometimes it is not something we get right away, and so you have to like take a deep breath and just try it out. So the 2.4 homework is on big ideas, okay? I am going to give you until Wednesday so that if you want to wait till after tomorrow's quiz to do that, you can. It is going to be due on Wednesday, okay? Tomorrow's the quiz on 2.1 to 2.3. Sure. Okay, again, 9, 10, 11, and 20 are ones that require work. So you're going to do that step-by-step process either in Notability or on a notebook piece of paper. Like, I don't care where you do it, but you need to show that work. And then at the top of this page, so eventually you're going to put it into Notability, even if you take pictures and put it there. You're going to create the PDF, and at the top of that page is going to be your score, okay? And again, make sure I can see your username where that score is. And then that's what's going to get submitted to Canvas.